All right, two more words I wanted to look at with you. So we're going to call a function between x and y. Here, x and y is our topological spaces. We're going to call a function open if, whenever you have an open set U under the topology F, that implies that f of U is open under the topology R. So whenever U is in F, f of U is in R. In other words, F takes open sets to open sets. I should squeeze that in a different color. I don't really have room. But F maps open sets to open sets. You can jot that down if you want to yourself. So a function f from x to y is called open if it maps open sets to open sets. And then similarly, we're going to call f closed if A, by the way, A is a subset of X. If A subset of X is F closed, let's actually erase this is. So if A subset of F, that's fine, is F closed, then F of A, which by the way is a subset of Y, is R closed. So in other words, F carries closed sets to closed sets. So I've given you a homework problem where I'm going to ask you to play around with that idea and to discover the relationship between homeomorphisms and then open functions and closed functions. So just a couple of last remarks. If f from x to y is a bijection, then so is, this is very clear, but so is its inverse, which is going from y to x. I just wanted to make sure that's clear. And then again, assuming f is a bijection, I'm assuming that for all of these. I'm going to maybe underline that for both of these parts here. 2 and 3 are still assuming f is a bijection. So in that case, if you start with a subset of y, f of f inverse of a is just a, and f inverse of f of b is just b. In particular, if x goes from x to y, and you have a subset of y, what I want you to realize is, let me write in a different color here, then the preimage of A under F, this is the preimage of A under F, is actually equal to the image of A under F inverse, and I meant to write it in symbols first because they look the same, right? This, which is it? Is it the preimage or is it the inverse? Is it the image of the inverse image? And so it turns out they're the same when F is bijective. That's really important. You need to know that you have an injection. So I'm not going to prove that. I would encourage you to play around with it, but you want to make use of this fact in the homework problems, and I don't want you to wonder about it. I wanted to go ahead and tell you that, yes, it's true. All right, so I'll post some homework for you guys, and we'll go maybe one more. I'm thinking probably just one more lecture after this, and then I'll have some information about some sort of final exam. So I'll be in touch. Hope you're doing well. If you guys need anything, reach out. A few of you have reached out. We've been able to meet over Teams. I'm always happy to try and arrange that. I've been swamped the last few weeks trying to make videos for all my classes, but I am seeing the light at the end of the tunnel. I'm going to make it, which is good. I wasn't sure. So anyway, please reach out if you're having trouble. And just keep in mind our goal, with all the changes, our goal in this class is the same as it was from day one. It was just to learn a little bit of mathematics for its own sake. Topology is worth studying for its own sake, but also to just practice working in a more of an abstract mathematical setting and thinking about proofs. And so I just hope that you've been able to continue to grow and work at some of these and learn. Let's just keep that goal in the forefront of our mind. Our goal is just to learn and to grow a little bit mathematically, and hopefully you've been able to do that. So I'll sign off. We'll be in touch.